And today we are specifically having a look at our product, SolarMD battery. So if you can just give me a thumbs up that you can hear me, or if you can see my screen, that'd be great. And then we can start with our training for today. Okay, perfect. Seems like everyone can hear me. Welcome, Mike. I see a very familiar face there. So today our focus will be SolarMD. So what we'll do first is I'll just give you a short introduction of IBC, and then I will then give Warren and Riska, who will be handling the whole technical training for today. Welcome, Riska and Warren.
Thank you, Alton.
Yes. Okay, so now we'll start with our IBC Solar introduction. So at IBC, we do offer modules, inverters, storage, and other accessories. And on our module side, if you can see from my screen, we do offer our own IBC modules, Longi, Jollywood, and Canadian Solar. And also on the mounting structure, we only specifically deal with our own mounting structure. We have your Aerofix mounting structure, which is one of our famous selling mounting structures, especially for your flat roof flat roofs. When we look at the inverter side, we do offer SMA, Fronius, Victron, Goodwe, Attest, and SunGrow. So when you look at our inverter portfolio, you can see these are very particular inverters which have good communication protocols with each other. So if you are looking for a solution, we are able to offer that from our inverter portfolio. And then on our storage systems, we do offer BYD, which is one of the global leading batteries out there, and one of our favorite local batteries, SolarMD, which will be today our focus. So on our team, we do have Daniel Heitzler, who's the managing director, with Helga, who's the head of finance and operations. And then on the marketing side, the two famous ladies, Zane and Carmen, who deal with our whole marketing and the main reason we have this training today. They organized everything, so thank you guys. And then on the supply chain and sales administration, these are the people who make sure that we have our orders, everything gets put into picking. This will be Charmaine, Kim, Michaela, and Tanya. And then on our accounting side, we do have Hamu. And then just for you guys to pay attention, so especially for our installers out there, if you don't know who your sales manager is, so we have Leo and Jason in Joburg. So Leo and Jason had the whole division that side. So if you're on the inland side, Mpumalanga area, Limpopo area, Leo and Jason will be the people that will be in contact with you to assist you with your orders. And then on the Western Cape side, the coastal area, we have David, Carl, and Rida. So this will be your sales managers. So if you don't know who your sales manager is, you can just drop your text, drop a text on our chat box, and then one of our people at IBC will reach out to you just to assist you on that. And then on the technical side, we do have Vessel. He is situated in Joburg, and he mainly deals with the inlands side, your Limpopo area, Mpumalanga area, Gauteng region. So Vessel will be your main guy that side. And on the Cape Town region or coastal region, we do have myself, Alton, Honte, and Jama on the technical division. If you do have any technical inquiries, please feel free to reach out to us. Now, we do have an IBC online portal training, which happens every second week of the month. So if you want to partake in that, please contact your sales manager. And as I said, if you don't know who your sales manager is, please drop it. Just drop your company name on the chat box, and somebody will reach out to you to assist you. And we do have a special going on this month. So our special, we have two specials. The first special is if you purchase a VCOM license, we will give you a 1-day remote commissioning assistance. So please note terms and conditions apply, but we will be able to assist you. You just need to then book at least 3 to 5 days before the commissioning date. And we also do have the Attest and SolarMD combination. So if you purchase an Attest and battery together, you will get a 1-day free remote commissioning. So everything is remote. Just so that you're aware of that. So please make use of this deal. get yourself the deal, make a purchase, and then we'll be able to then assist you in that. So please note that even if you make the purchase this month, we will be able to assist you in commissioning if you are then do the installation maybe 1 month down the line. And that is it from my side. And I'd just like to give this chance to, I'm not sure if Riska is starting, but between Riska and Warren, to then start on the training for Solandi. Welcome, Warren and Riska.
Thank you, Alton. Just give me a second. I'm just going to share my screen quickly.
You're going to have to speak up.
No problem. So please note, if you do have any questions, drop them on your chat, on the chat box, and we will then try to answer all questions as soon as possible. And if we don't get back to you, we will then just drop you an email to then assist further. If you're not registered with IBC yet, please drop your email, and Zanil will then send you a checklist to get your company registered.
Use that diaphragm.
Thank you, Alton. Can everybody see my screen?
Yes.
Hello, everyone. Okay, thank you. Hello, everyone. Good morning. I'm Riska, and I'm the product manager here at Solar MD. With me is Warren.
Good morning.
Warren is our technical support supervisor, and today we will be going through our product webinar. So basically, this is just a brief overview of the products that we offer, and then some of the key features. Okay, so firstly, let's just go through the content. So in this webinar, we'll firstly cover an overview of Solar MD, so a company overview, as well as our product range. We'll focus on the low voltage battery range and our high voltage battery range. We'll also go into detail on our Logger V2 that we offer, as well as do a MyPower 24 portal demo and a battery energy storage system overview. So firstly, we'll start with the company overview. So Solar MD was founded in 2014 by a group of engineers. What they found when they came to South Africa was that there was definitely a shift. There was a need in the market for energy storage. So their vision was to bring affordable, clean energy into every African home. And the focus of Solar MD is on efficient battery energy storage. So they saw a need for energy storage as they started out as installers within the renewable energy sector. So that is essentially how Solar MD began. And as time went on, they moved on to developing full battery control technology as well as monitoring systems. Our systems ensures durability and cost effectiveness, and we also created our own battery management system. This has shown for the end user specifically good return on investment for residential, commercial, as well as industrial use. And we are currently producing and delivering commercial and residential energy storage solutions across Africa. Okay, so Solar MD is located in Cape Town, South Africa. So here I've added in a nice picture of our new facility that we will be moving into towards the middle of the year. So this facility is located in Richmond Park. And then on the right-hand side, you can see the map of the world. And we've also indicated our presence. So from the, sorry,
Mariska, I think your presentation just shows you're not seeing the whole slide. I think, yeah.
Oh.
We're just seeing the whole, the
slide
PowerPoint,
deck.
the slide.
Yeah.
Yes.
What is?
I think we might have it on the other page. There we go.
Okay.
And then.
Stop sharing.
Okay, we'll reshare, sorry.
Just rather go to the screen,
Yeah.
the full screen. And start the slideshow, make it full screen again.
Can you see my
Perfect.
screen now?
There we go.
Okay.
Perfect. Thanks.
Okay, so as I said, this is a picture of our new facility that we're moving into in the middle of the year. And then also SolarMD has a factory in Europe. We have a factory in Bulgaria, so we are building our European presence. We are also looking to have an HQ in the Dubai region as well. So we are gradually expanding. Also from the map, it's indicated there in Asia. So we also have a procurement team in China that essentially procures any of the components that we require for our batteries, and they are there in China, employed by SolarMD and assisting us in that regard. And then global presence. So SolarMD has now supplied over 50 countries. We have our energy storage products in 50 different countries. The company itself has seen a 300% increase year on year in terms of growth. So we are growing quite exponentially, and we also expanding, as you saw in the previous slide. So a bit more about the company and employees as well. So we have a good research and development capability. So our R&D departments span over 3 different departments. We have electrical engineering, mechanical engineering, as well as software development. So we specialize in the in-house development of electronic equipment. So our BMS hardware has been manufactured and designed in-house. It has been designed in-house. Our energy management system has also been designed by engineers, as well as our Logger V2. So all of these components that you find in our batteries has been designed by our engineering team. And this allows us to provide quality and optimal performance for the end users. And our team ensures that everything runs smoothly for the design and production processes. Then moving over to software engineering. So by now you may have seen our MyPower24 portal or interacted with it. And this has been designed in-house by our software engineering team. They are responsible for crafting the MyPower24 platform, the energy management system, as well as our battery management software. So everything has been designed and implemented in-house to allow for seamless operations. And then moving over to our mechanical engineering team. So we have a comprehensive mechanical engineering department, and our mechanical engineering department is primarily responsible for our battery energy storage systems. So they essentially oversee the entire product life cycle for our battery energy storage systems. So from initial design, everything that you see in our containers has been meticulously designed by our mechanical engineering team. So they oversee our commercial battery energy storage systems, and they also play an important role in our manufacturing of our low voltage batteries as well. And then production wise, so obviously SolarMD is a production facility, and we specialize in lithium iron phosphate batteries. So at our facility, we have various production staff, and their roles shift between battery assembly, working on our battery energy storage containers, and also the fabrication processes, ensuring that every piece of metal is cut and fitted to ensure that we can deliver our battery energy storage systems. So currently we produce around 1 gigawatt of energy storage annually. And as we're now moving towards our new facility, this will be increased to around 3 gigawatts. So I've included a video here just for you to have a little bit of insight into what production looks like for one of our batteries.
Say it again.
Okay, so we're just waiting for the, there we go.
Apologies if there's an
Yeah.
advert.
Riska, the video is not playing with audio. I think you had to join with audio. So I'm not sure if there's a voice
Oh,
over
sorry.
in the video. But if there's not a voice over, it's not too long, we can just watch.
Yeah, it's just music, so it's fine. You can just.
Okay, no, then it's fine. Also, just know there is a question in the chat section for you.
Okay.
So I suppose I can explain what's going on here. The production team are installing the top plate that includes the bus bars. The bus bars are currently being laser welded onto the top of the cells. It's quite an intricate process to get right. You're welding the bus bar onto the cell. You want to make sure that the weld is strong, it's consistent, but you don't during this process necessarily want to inject too much heat into the cell, as it would obviously cause damage. So that's quite a dance to get done correctly. It takes a bit of finesse. Laser welding is obviously the way to go about doing that. In years gone by with previous models, that would have been done with nuts and bolts and bus bars. But obviously we progressed and have been laser welding our products for quite some time. It's the modern way of doing things. It allows for greater consistency and I guess ultimately better longevity, better performance. But I'm going to hand over to Riska.
Thank you, Warren. Yeah, so that's basically a look into what the production of our 14.3 kilowatt hour lithium iron phosphate battery looks like. And then a bit more about the company. We have a very strong technical support team at SolarMD. I think this is definitely one of the key aspects that sets us apart from other battery manufacturers is our strong technical support. So essentially, our technical support team will troubleshoot any issues that you have related to low and high voltage. We have a low voltage technical support department as well as a high voltage technical support department, and they assist with firmware updates, BMS replacements, and also if you are on site and you require assistance with an installation, they're able to assist you remotely, and they're available Monday to Saturday via our WhatsApp chat.
I'd like to add that if you wanted to speak with someone telephonically, you are welcome to call the company landline, and they'll put you through to the technical support department. We just find that dealing with end users, installers, EPCs, it's much more efficient dealing with them via WhatsApp, as we're able to share multimedia content in a much easier fashion. And instead of having someone describe the problem, we can see the problems with pictures and videos, and we can reply with the necessary instructions and text, as well as videos on how things need to be done. So that's our primary means of communication, but it's obviously not our only means. So if you want to speak with us, call in. You're always welcome to email, but 90% of our communication is instant messaging, and that's done via WhatsApp at this point in time. So am I taking it from here, Riska?
Yes.
Okay.
Warren,
Alrighty.
over to you.
Okay. You'll have to forgive me. My role within SolarMD is a technical support supervisor. I focus on the team that does the bulk of technical support for the company, and that focuses on our low voltage products. So what I'm saying is I'm not a salesperson. So if this is not the slickest presentation with the best words chosen, please forgive me. I'm a bit more practical. Okay. So at the heart of the battery is the BMS, and we use the same BMS in our high voltage and low voltage batteries. The only key difference there is how the BMS is programmed. It has different operational modes, and it's set accordingly. From a manufacturing point of view, using a single component as opposed to multiple is going to be a lot more efficient. It means that we always have stock of said component, and yeah, it allows us to have greater consistency in providing the product and troubleshooting any problems. The BMS is necessary with lithium iron phosphate batteries, as the lithium iron phosphate cells, of which there are 16 inside our batteries, need to be balanced. This wasn't necessary in older energy storage technologies like lead acid batteries or PV batteries. With lead acid batteries, balancing wasn't really too much of a concern. To use lead acid terminology, you would refer to balancing as equalization or equalizing thereof. And so if you look at a standard 12-volt lead acid battery, there are 6 cells, 6 2-volt cells in series inside your average car battery, as an example. And should one of those cells be lower than the other 5, you essentially correct that through the equalization process by essentially overcharging the battery. And you overcharge the other 5 cells and bring up the 6th cell that is low to the necessary voltage. That process is possible with that old school chemistry, because what happens is the excess energy in the other cells that are higher are now essentially being overcharged. That excess energy is given off in the form of hydrogen gas. You lose liquid, assuming it's a flooded lead acid battery. And that's not too much of a problem, because you can always add that liquid back. If it's an AGM battery, as an example, that would sort of coalesce and probably stay within the battery, and things would be fine. So equalization wasn't a technical challenge with old school energy storage solutions like lead acid. However, with lithium iron phosphate, you can't take the same approach. If you had to overcharge a cell, it would be damaged permanently, and you can't leave a cell in a low state and have an unbalanced pack. You can think of the 16 cells that are inside the battery as like a chain with 16 links, and the chain is only as strong as its weakest link. And so one of the core functions of the BMS is to balance the voltages or the state of charge, essentially, of each cell, each of the 16 cells within that battery. How this is done and how fast it's done depends on the design of the BMS, and that varies from brand to brand. Within SolarMD, our BMS design has improved over the years. Our earliest batteries, you're talking 10 years ago, didn't even have a BMS. There was no balancing of any sort. Then we came out with the PL series BMS, which essentially mostly did voltage measurements and state of charge reporting to the logger, and that didn't do balancing yet. It was only until we released the EM series of BMS that then started balancing the cells, and that itself only balanced one cell at one time, which in the early stages of any battery's lifespan, that's sufficient. I think as the battery ages and works harder, then the rate at which things need to be balanced tends to increase. So with the current design of BMS, it can balance up to 7 cells at one time. It can do more, but the default configuration on our BMS is it's 5 to 7 cells at any one time. So that keeps the cells in line. That makes sure that you get the sort of maximum performance out of the pack. As I said, it's the chain is only as strong as its weakest link, so you want each of the cells to be at the same or relatively close state of charge. Another obvious function of the BMS is the pack voltage measurement, which it's going to report to your inverter, so the total voltage of the whole pack. The BMS will also report on the individual cell voltages. And the key feature with lithium iron phosphate, or challenge rather, with lithium iron phosphate is reporting or knowing what the state of charge is inside the battery. And that's because again, comparing this current energy storage technology to old school lead acid, with lead acid, you could know relatively well how full or empty the battery is based on its voltage. And so if you look at the voltage discharge curve of a lead acid battery, it tends to discharge, that voltage drops at a relatively linear rate based on the state of charge. So if you just measure the voltage of the lead acid battery, you would know roughly how full or empty it is. However, with the underlying chemistry of lithium iron phosphate batteries, upon which ours are based, when you look at the voltage discharge curve, it tends to drop off very quickly, and then it plateaus with a slight downward trend for a very, very long time in terms of that voltage drop. And it's only when the battery is basically depleted that the voltage tends to fall off a cliff, for want of a better description. And so, for 80% of the time, if you were trying to guess the battery's state of charge based on voltage, you wouldn't know where you were. And so what the BMS does is it with the aid of a shunt, which you can see is that big brass lump of metal on the far right of that image of the BMS, with the aid of the shunt, it measures how many amp hours have come and gone from the battery. And the BMS will know the size of the cells. So in the case of our older 7.4 kilowatt hour batteries, that cell size is 144 amp hours as an example. The BMS would see that, 140 amp hours have, gone out of the battery. So it would know that the battery is basically depleted. And the BMS would report the state of charge of the battery either on the push button, the multicolored push button on the front of the battery, and it would show you that it's red, meaning the battery is basically depleted. And if you have communication set up between the BMS and your inverter, or in some cases via the logger, that information is then reported to your inverter of choice. So you could see this on the push button of the battery, you could see this on the inverter's interface, and if you have our logger attached to the battery, you could see this via the MyPower 24 portal. Other roles of the BMS in terms of communication with the inverter is the BMS will report to the inverter how fast the battery can be charged and discharged. So obviously every battery has a limit, and this is referred to as the C rating. And the BMS would say to the inverter, listen, you can discharge me at 100 amps, or you could charge me at 100 amps. So the BMS communicates this critical information to the inverter so that the inverter knows what it's working with. The BMS also handles the rate at which it's charged during the charging process, and it may increase or decrease those values as the batteries reach a full state of charge or are reaching the bottom end where they are depleted. The BMS will adjust the amperage that the inverter is allowed to use. The battery doesn't tell the inverter explicitly what to do, but it does send its limits. So it will via the BMS, it'll say charge me at maximum rate or don't charge me any further, and the inverter should adhere to the guidance of the BMS. However, if the inverter does not choose to do that, then the battery will then kick in its self-protection mechanisms and open the relay on the battery, protecting the cells from any damage. So the BMS has a very important role to play with lithium iron phosphate storage. It prevents any damage to the cells from being overcharged or discharged too far. Okay, let's carry on. So, well, looking at the picture of the BMS, just to give you an idea of what you're looking at. Like, as I said, on the far right hand side is the shunt, the thing that does the current measurements. On the bottom there of the BMS, you'll see there's 4 network ports. They look like network ports. They are RJ45 connectors or LAN connectors, the kind of connectors that one would see at the back of your router or on any Ethernet switch. But these are actually CAN bus ports, which is a common means of communication between equipment of this type. The two ports on the far left are used for communication between multiple solar ND batteries and our logger. The two ports on the right are used for communication between the batteries and inverter. Okay, next slide. Okay, so I think it's important to note that the BMS does the measurement and reporting of all of these values that are displayed here, the minimum and maximum cell voltages, the temperatures, and so on. It reports these values. If you want this information recorded or logged or graphed somewhere, it's going to be your inverter and its software platform that's recording this information, or the solar ND logger. Possibly both in some cases, as some of our customers use both the inverter brands portal as well as our logger simultaneously. Okay, so that's just a close-up of the battery. We were looking at some of the key features on it. As I said, shunt on the far right-hand side, CAN bus communication on the bottom. On the far left, you're actually seeing the cell balancing circuits. The balancing method that our BMSs use is known as passive balancing. So essentially, it's a couple of resistors in series. And so when one of the cells have a higher voltage above a preset threshold than the rest, that circuit closes, and we burn off the excess energy through heat. There's an alternative to this, and that is active balancing, where essentially it would shift power around between the cells, and that's quite expensive to produce, more complex, and that would raise the cost of the battery significantly. And so that's not really a solution that we offer, but passive balancing gets the job done in a cost-effective manner. Okay, so here's the slide with most of the things that I've just described. But looking at the LED indicators on the left-hand side here on the BMS, you can have the status light here on the top left. Generally speaking, that should be green. The warning light will illuminate orange if there's a problem. The warning light would say, that the BMS is not happy about the state of something. This could be a cell that's a little bit too high or a bit too low. One of the batteries that's maybe missing from the cluster, as an example, a loss in communication with the inverter. Those are the kinds of things that the warning LED is telling you about, saying, I need some attention, take a look at me. The error light would illuminate red when there is a more significant problem. Let's say the battery is being over discharged or overcharged. In that case, the relay on the battery would open, protecting the cells from being over discharged or overcharged any further. And an error is, let's say, a non-negotiable. You need to investigate. If you want to continue using the battery, pulling energy out of it or putting energy into it, you need to address that problem. Below the status LED indicators are 6 LEDs. And these can display information in a number of ways. They can tell you by default whether the battery is receiving a charge or whether or not the battery is being discharged, and a rough indication as to if it's being charged quickly or discharged quickly. Most people, do not refer to these LEDs because it's located on the inside of the battery, and so it's only there for if you're working on the battery on site. It's useful to have, but most people don't refer to these. Below that are the CAN bus status LEDs. Green is good, just like the green revolution and the green renewables industry. An orange LED CAN bus indication means that there's a break in communication or a problem with the communication between the battery BMS and, say, other batteries or the inverter. So that's what that means. The CAN bus termination switches, which you can see on the right-hand side here of the slide, are necessary when it comes to CAN bus communication. It's basically a resistor that needs to be enabled at the end of the CAN bus line. Maybe this is too much detail for the sake of this session, but the point of that resistor switch that you enable or disable, depending on how many batteries you have, is to essentially prevent reflections on the CAN bus communication network. So, you know, the signal, the transmission is being sent out by the various devices. And if there is no termination at the end of the CAN bus line, then that signal is reflected much like an echo back up the line, and that's basically becomes destructive interference. Think of it like excessive echo or noise, and then communication can't happen effectively, and devices are not able to communicate, and things will appear to be offline when they are not. So these termination switches need to be configured, and how they need to be configured depends on how many batteries you have within your energy storage solution. And if you have any questions in that regard, you can always message into the technical support department, and we can explain it to you. It's not particularly complex. It's a pretty straightforward process. Turning a switch on and off, I'm sure all of you can manage that. So our low voltage energy storage solutions have been condensed into, at present, just two solutions. The first of them being the SS4083, which is a relatively new offering from Solar MD. If some of you have dealt with the brand in the past, you'll be familiar with the SS4037 and 74. Those were, in plain English, a 3.7 kilowatt hour battery and a 7.4 kilowatt hour battery. This model here, which is an 8.3 kilowatt hour battery, has replaced or superseded those two. Those were the batteries upon which, I guess, Solar MD was, I won't say founded, but most of our success was thanks to those two models. We didn't necessarily want to discontinue them, but the cell upon which both were based was discontinued by the manufacturer, so we had to make that change. And if you're changing cells in batteries of this type, it necessitates a full redesign, a new casing, a new layout, you know, different length bus bars and so on. So that's why this new model was released. Slightly more capacity than the older 7.4 kilowatt hour model. I think it's worth noting in terms of Solar MD's batteries designs that they are quite compact. They're very energy dense for their footprint compared to some other brands. If you ever pay our factory a visit and you see how the batteries are designed internally, you can't actually pack things in there more tighter than they are. In terms of the layout of the cells, how closely they are joined and so on. So it's a tiny footprint relative to the energy density. The only way that that's going to improve is with advances in the lithium iron phosphate cell design. Okay, so I think if you're the average installer and you look at this 8.3 and you think, okay, well, can I install this on my own? I'm a one-man band. No, I wouldn't recommend picking up this battery on its own. I'm sure some of you are strong enough, but I would suggest rather, make it a two-man job. It is 70 kilos. I think my personal limit's about 60. You'll put your back out if you had to try and mount this on your own. So the battery does come with wall mounting brackets. That's what most end users prefer. Keeps it off the floor, keeps it away from undesirable risks. Like physical damage, water damage, insects, rodents, who knows. Wall mounting seems to be the preferred method, and it can be mounted near the inverter, which in most cases is inherently wall mounted. So the nominal voltage of this battery is 51.2 volts, which is supported by most, if not all, inverters these days. If you want a bit more theory as to why it's 51.2 volts, that's because with lithium iron phosphate batteries, this is the closest match that one could have to lead acid batteries. And if you've been around long enough, you'll know that the 48 volt standard was the most popular for larger domestic applications. So that's why we use 16 cells. That's why it's 51.2 volts. It seems to be the common standard that most inverter brands are using, but not exclusively, because I have seen some other brands who use 15 cells, but I think that's pretty much faded away. So what else do I want to say on this particular model? So the C rating of a battery is always a consideration. The C rating defines how fast energy can be put into the battery and how fast energy can be taken out of it. The C rating on our batteries on the 8.3 and the 14.3 kilowatt hour is 0.7 C. So if you're looking even at all the batteries like the 7.4 kilowatt hour model, that means it could deliver up to 5 kilowatts, but the energy storage, the capacity in kilowatt hours is 7.4. The same applies here. The cell itself is actually a 1C cell, but we have left a bit of headroom, and that's why it's rated at 0.7 C. And so the bus bars internally and the relays and everything are designed within those limits, including the fuses as well. You'll notice on the data sheet here they also talk about the temperature. With lithium iron phosphate chemistry, the ambient temperature that it operates within is crucial if you're wanting a long lifespan, to have a great number of cycles, to have the battery deliver many megawatt hours worth of power over 10 or 12 years. The environment within which you install it matters greatly. And so there are some situations where you don't have control over this, but you want to keep these batteries, and I say this, it's not a brand specific challenge, but it applies to anyone using this battery chemistry. You want to make sure that the environment is at room temperature, as in 25 degrees or a bit less. So it's very much like the temperatures that you would enjoy as the average human. That's the temperature at which these batteries would want to operate at for extended periods of time. So you don't want to install this battery in an environment where it's 30, 40, 50 degrees. You can, however, you will greatly degrade the lifespan of the product. Again, this is not a brand specific challenge. It's not a solar MD problem. This applies to any battery using this chemistry. But it is worth noting, since I have your attention and this is a training session, it may be necessary in some environments to install extractor fans, to install air conditioning. It is necessary, and any one of these batteries is a significant investment, and you want to protect that investment. You want to have consistent performance over time. You want to see 10 or 12 years worth of use. Therefore, you're going to want to make sure that the environment within which the battery is installed is going to give you that longevity. So on the current generations of batteries, it's a 12-year warranty. There is a 6,000 cycle limit depending on the model. But in order to achieve that, it's also down to your installation environment and so on. Okay, I'm just checking if there's anything else I wanted to add. Okay. So the most popular seller for us at this point in time is the 14.3 kilowatt hour battery. It is available in a rack mount variant, which may or may not be in slides coming up, known as the SS214. So if you're installing multiples of these batteries, say more than 2 or 3, you might want to consider the SS214 and the appropriate racks that go along with it. It'll make the installation a lot easier and a lot neater. So yeah, for the average domestic installation, there's normally 1 to 3 batteries, and wall mounting them is fine. Anything beyond that, I would suggest look at the SS214. It's the same battery in a different dress. The cells and the layout thereof are basically exactly the same. Instead of having 2 rows of 8 stacked on top of each other to give you this narrow profile of the SS4143, you've got 2 rows of 8 side by side. So there's no performance difference in any way. It's just a different form factor that can scale better because it's rack mountable. Of course, the SS4143 is a substantially larger battery than the previous one I've just looked at. It's still very energy dense. It's still as compact as one could hope it to be. Comes in at a hefty 114, 118 kilos, so definitely a two-man job. Wall mount brackets included. Also, nominal voltage of 51.2 volts. The amount of power that it can deliver is up to 10 kilowatts or 200 amps. The cell within the battery is actually a 280 amp hour cell, but the design of it means it can deliver up to 200 amps or 10 kilowatts, which we feel is the sweet spot for the average domestic installation or small business needs. So yeah, just coming back to the topic of C ratings and how fast the battery can charge and discharge. Again, this is up to 10 kilowatts or 0.7 C in the case of this model. You might ask yourself, well, why is it that the battery is not 2C or 3C or 5C? And those cells are produced obviously by the same manufacturers that we purchase the cells from, but they come at a greatly increased cost. And those cells are mostly designed for different applications in different environments. So, you know, if you look at the average electric vehicle, EV applications, those cells would want to be charged at much more rapid rates and discharged at much more rapid rates because you have a great demand from a few massive motors somewhat instantly. Static storage solutions like this, the charge and discharge is often a lot more gentle. And so we could produce a battery that maybe offered 2 or 3C. However, it's going to come at a greater cost. And there's also performance costs as well. The cell's going to be larger and it's going to raise the price of the battery. So for us, we feel that the C rating that we have is the most cost effective and it meets the greatest needs and is reasonable within the environment that we plan them to be used. Okay, so what I've said previously about temperatures and so on, that applies to this battery as well. The cell in the SS4143 is made by CATL, so arguably one of the biggest and best cell manufacturers in the world. Yeah, the cell is the building blocks, obviously, of the battery, and you know, everything else on the battery can be great. It can have a fantastic front cover, an amazing BMS, the best support, you know, the best user interface. But if the cell upon which the battery is based is of a poor quality or from a questionable manufacturer, well, then you know, you're always going to end up with a high degree of failure or poor performance. So, you know, we've pretty much chosen the best as far as we could. So yeah, the cell offers up to 6,000 cycles, and you'll note there on the data sheet that it says they're at 25 degrees. So if it's sitting in a 35 degree or 40 or 50 degree environment, then the number of cycles that the battery could perform is going to be a lot less. And to use an analogy from the IT world, if you look at the mean time before failure on computer hard drives, you know, old school disk drives, you go look at how quickly those fail as the temperature increases, and the same logic applies here. And it applies to electronics in general as well as the inverter. You know, you never want hot electronics, and you don't want hot batteries, and you definitely don't want hot circuit breakers and bus bars. You've done something wrong if that is the case. Okay, so looking at our high voltage, well, before I get to the high voltage, I wanted to add that you can certainly parallel multiples of these batteries. So if you wanted more than 14 kilowatt hours worth of storage, you can have many of these running in parallel. Of course, you know, it becomes cumbersome at a certain point to have, you know, 20 or 30 or 40 of these batteries running in parallel with a low voltage system. At that point, you would rather consider a high voltage solution and a high voltage energy storage solution and a high voltage inverter. But sticking with the topic of paralleling batteries, with our brand, you can mix and match this current generation of battery with the older batteries that we produced in the past. With other brands, this is not possible. I'm not going to mention any names because they've changed the underlying cell chemistry, and then you can't mix and match at all. But with Solar MD, it is possible to take a and we've seen this as customers' needs have grown and they've had more money available to them. They started out on a 3.7, then they added a 7.4, and then now they've got an 8.3, or they've mixed a 7.4 with a new 14.3 kilowatt hour battery. It is possible to parallel them in that way. Of course, it's crucial how you do the DC cabling to ensure that the most even performance of both. And since I'm on the topic and I deal with some challenges in technical support, I think it's worth noting the following, and forgive me while I take a drink of water. When you're mixing batteries of different ages, you'll find, and this applies to Solar MD and any other brand of battery, if you're mixing low voltage batteries of different ages, they will charge and discharge at different rates. So this is a bit of, say, pre-sales advice to you. Batteries that are, say, older than a year, maybe 2 years older, and they've done a lot more cycles, the cells build up a higher internal resistance compared to the new battery that you might be installing today. And so you'll find that the newer battery will counterintuitively discharge faster, meet the demands of the system ahead of the older battery. Because as you know, electricity tends to take the path of least resistance, and you've got this new battery with young, supple cells with a low internal resistance. That newer battery is going to deliver the power sooner. So you'll find that the newer battery will discharge quicker as a result. The older battery will ultimately catch up and take over more and more of the load as both batteries reduce in their state of charge. But it's just something that's worth noting. And I've worked at another battery manufacturer in the past, and I saw the same effects there as well. So it is possible to mix and match batteries of different ages from us, and parallel multiple batteries for larger energy storage needs. But just be aware that with significant age differences, there are certain challenges, and it's down to physics, sort of core electrical principles that can't be overcome. And you can't fix that with software or any magic from the support departments. The electricity will flow where it wants to. I suppose if you have any questions on this topic, you can raise that with us towards the end of the session. So as I was saying, at a certain scale, it's not practical to have 20 or 30 low voltage batteries in parallel. Wiring becomes cumbersome, the bus bars become too long, takes up a lot of space. And so that's why we offer a range of high voltage energy storage solutions, as you can see here. And this is based upon the same cells as the 14.3 kilowatt hour battery that you saw previously. It's the SS214, but with a slightly different layout. The BMS is running in a different mode. It doesn't have a relay. It's got a much larger fuse on it and different connectors. So there's no internal bus bars. The connector type is different. But ultimately, it's the same battery, the same cell, the same quality, the same performance. The layout's different. And our high voltage batteries range approximately from 400 volts to 900 volts, and that meets the needs of most of the common inverters in the marketplace. I suppose one of the most popular, let's say, cost-effective inverter brands out there is ATIS, and of course our batteries support them as an example. So in the case of the series, you just add as many modules, battery modules, as are required to meet the voltage requirements of your inverter. So the minimum is 4 battery modules, 8 battery modules in series, and you can grow it from there depending on your requirements. Now, if the total kilowatt hour storage is not enough, then you can parallel multiples of these high voltage batteries. So if you look at our containerized solutions, where we're dealing with 1 or 2 megawatts with power or megawatt hours worth of storage, we run multiples of these high voltage batteries in parallel. So you can do that too if needed. Of course, the advantages of running batteries in running high voltage batteries is that you're gonna you're going to suffer less loss in terms of the transmission on the cabling and connectors and so on. It's a lot better to work with. I think, look, in my opinion, and this is open to discussion, especially with the experts at IBC, that sort of threshold is normally about, what, 50 kilowatts, I would say. So, you know, if a customer is needing a storage solution or solar solution and you're looking at a 50 kilowatt inverter, or you're trying to meet that sort of demand, that's the point at which you should consider looking at a high voltage solution. But that's just my opinion. Okay, so yeah, here we're looking at the internal structure of the high voltage battery. As I said, it's made up of a number of battery modules, and you'll notice there on the top left of the stack is the BMU. The BMU then becomes the brains, if you will, of this high voltage battery. It's the device that reports the state of charge and all the other warnings and alarms to the inverter. This is where the DC connectors are for the battery. You'll notice that there's a large on-off switch on the face of it. There's also an internal relay that we're able to control via the logger or remotely, so we can turn this battery on and off remotely as well. So yeah, here's a breakdown of the high voltage battery itself. It's not really any more complex than any one of the low voltage solutions. There's just more components involved. So of course, all the battery modules are connected in series to one another. Each battery module is fused. Inside the BMU, there is a larger single fuse as well, so there's plenty of protection in place. So you've got a manual on-off switch, you've got an internal relay that we can activate if necessary. All of these individual battery modules communicate amongst themselves and report their collective data back to the BMU. And that BMU then takes all of this data and reports it back to our logger. So via the MyPower24 platform, you could see the individual cell voltages on any one of those battery modules, which is immensely powerful, especially if you're trying to troubleshoot issues. You can see the temperatures of any one of those battery modules as well. And since I'm using the word module so much, that reminds me that the design is inherently modular. And you think, okay, wow, amazing. What does that mean to me as the installer? Well, when you look at other brands and their solutions in the marketplace, they produce, nice enough high voltage batteries. However, to meet your energy storage requirements, if you want an 80 kilowatt hour battery or a 200 kilowatt hour battery, they produce one large single battery. And that becomes a logistical nightmare to get this battery to and from site. Moreover, if you are facing problems with the battery on site, you can't easily repair it on site, and you can't exactly return the faulty component to site. Generally, it requires the manufacturer to come out to site with their team and fix things on site. Whereas with a design like ours, being modular, if there's a problem with the BMU, you can replace that, and it's relatively easily removed and replaced. If there's a problem with any one of the battery modules, the same applies. You can shut the system down, you can pull that battery module out and install a new one. If there's a problem with the BMS, it's even easier because it's a little circuit board. It's very easy to swap a BMS on site. And so this modular design just means that you're going to have an easier time getting the battery to site, commissioning it, physically installing it, and if God forbid there's a problem, it's a lot easier to resolve because you can just take out one of the components of that and replace it, versus then trying to concern yourself with, I don't know, forklifts and cranes and those sorts of logistical nightmares dealing with immensely heavy things. So it's a lot more practical and a lot easier to deploy as the EPC or as the installer. So yeah, here we're looking at the face of the BMU. There's communication ports, there's the switch, there's the DC terminals. On the far right, there's the canister fuses for the electronics inside the BMU. Nothing too exciting. Inside the BMU is the larger 250 amp fuse, which can be replaced if necessary. Looking at the face of one of the individual high voltage modules, you'll see there's the 250 amp fuse on the module, 200 amp fuse on the inside of the BMU. You'll see there's the DC connectors, the BMS, which you are already familiar with, the bus bars coming out of the pack, and there's not much more to it than that, other than the telecommunication ports on the far left, which are obviously interconnected between all of the various modules. So it's pretty straightforward. It's similar to what you've worked with the low voltage batteries. The configuration of the BMS is different, but it's because the design is so similar, and because we're effectively producing the same battery over and over using the same BMS, that just allows us to have a greater degree of consistency in terms of, you know, design, worrying about any technical problems, having any, I don't know, warranty related issues. You know, we're making the same product over and over versus other brands who, if you buy a high voltage battery, you're getting something entirely different. Okay. So the Logger V2 is critical for any high voltage installation, but optional with the low voltage batteries. Personally, I would prefer it if everyone installed a Logger with each and every one of our batteries, as it makes my job as the in support a hell of a lot easier, supporting you, the installer or the end user, remotely if a log is attached, as it gives me a greater degree of insight as to what's going on the inside of the battery. This is opposed to reading the LEDs and the error codes that are displayed on the BMS. That'll give you some degree of information if there's a warning or error, and it'll tell you basically what the problem is, but not specifically. You know, the logger and the kinds of information it pulls off the batteries and off the rest of the inverter if it's attached, aids us greatly and helps us help the installer a lot faster in identifying the issue. There's a lot less guesswork that's involved. So, you know, it just means resolving any technical challenges a lot faster for us as well as the installer, keeps the customer happier. You know, the alternative is that you're running only direct communication from one of our low voltage batteries to the inverter, and there's a problem for whatever reason, and we now have to interpret what is going on the battery via that particular brand's portal or their user interface, and sometimes it's not as obvious as it would seem. And so having a logger installed, allows us to help the installer, the EPC, look like rock stars in the eyes of the end user, the customer or the business. So the logger is effectively a small computer. It's essentially running a Linux variant, upon which there's an additional daughter board that has additional interfaces on it. The logger's got a couple of Ethernet ports. It's got a couple of Wi-Fi interfaces. It's a router in its own way. So the logger can connect to the customer's Wi-Fi network on site, or be cabled into the customer's Wi-Fi network on site. Sorry, Ethernet network on site, not Wi-Fi network. So you can go wireless or you can go Ethernet. You know, what's best for you depends on your situation. You know, when it comes to Wi-Fi networking, I do know a fair amount on that, and even the best Wi-Fi networks, even the best routers have issues at times. So Ethernet cabling is often best. Just in terms of the average residential installation, most people don't have good Wi-Fi coverage within their own home, let alone the garage, as an example, where most inverters and batteries tend to be installed. So if you're installing the logger in someone's garage, make sure that there is adequate Wi-Fi coverage, or you've put a larger antenna on. Those are the challenges of Wi-Fi networking. Cabling is always best, in my opinion. So the logger is what collects all the data from the batteries or battery and ultimately reports it back to the MyPower24 portal. We'll take a look at the portal, just a basic view of a couple of sites, just to give an insight as to what can be done. But if you're setting up the logger as an installer, it's very much like setting up a Wi-Fi repeater. You'll power the logger on, and the logger is quite flexible in how it can be powered. It can be powered via the USB port. It's got a USB-C port on modern variants, and older versions, so it's a micro USB. So you could power the logger off a 2-amp cell phone charger if necessary. You could power it off a power bank if you're using it temporarily at an installation to see what's going on. But the best method is using the DC terminals on the top left-hand side of the logger, and it accepts quite a wide voltage range, 9 to 65 volts. We recommend 24 volts and up, but most people will power the logger directly off the bus bars on one of the batteries, or if there's a common bus bar, they would power the logger straight off that. Right, so in terms of powering it, it can be done either way, DC terminals or via USB. USB is normally the backup, but isn't necessarily the preferred permanent way of getting it done. Once the logger is up and running, the logger will broadcast its own Wi-Fi signal to which you can connect your laptop or smartphone, and then you can begin configuring the logger to connect the logger to the customer's Wi-Fi network, or making the necessary changes on the logger to add and remove solar MD devices and inverters and so on. So again, it's much like a Wi-Fi repeater. It'll broadcast its own signal, you'll connect to it, you'll tell it what Wi-Fi network it must connect to, it'll associate, and then the logger will be accessible as it will connect to our cloud service. And using the Solar MD app on your smartphone or the MyPower24 portal on your browser, you'll be able to access this logger remotely. So anywhere in the world, and pretty much any time. So this is a value add. It's not a paid for service. You know, we've got loggers installed all over the globe, you know, even on the island of Hawaii, as an example, on more prestigious islands like Tunda Island, as an example, which is a 5 or 7 star resort. So this sort of cloud service and feature is crucial. You as the installer would have your own profile on our portal. You would have all of your customers or installations loggers listed there, and then you could access any one of those installations as you please. Okay, so sticking with the interfaces on the logger, it's got serial or RS-232 interfaces on it, and that's used to communicate with these days legacy inverters like say the Voltronics Expert inverters, as an example. It's also got RS-485, which is used more commonly on SunSync inverters for communication with them and pulling data from the inverters. And then most importantly is the CAN bus communication ports on the bottom right. These are used for communication from the logger to the batteries, and in some cases, feeding battery information to the inverter on the CAN bus 2 port. The logger also has relays on it, and these relays, these are dry contacts, so it can simply open and close a circuit. It doesn't provide any power. But these relays are useful in a number of ways, as most people will end up using the logger to enable on a generator with remote start. So you can program the logic on the logger to say if the battery reaches a predetermined voltage, so let's say something low like 52 volts or 51 volts, or a low state of charge, say 20% remaining, that the relay must close. And this would start your generator that has the remote start function. And so that's the most common use of the relays. Of course, it can be used in a number of ways. I suppose your imagination is the limitation, but that's the primary use for the relays with most customers. Just in terms of warranty and so on the logger has a 1-year warranty on it. You know, for manufacturing faults, water damage, lightning strikes, acts of God are excluded, of course. But, you know, we often repair loggers that are well out of warranty. That's just a value add from our end. We'd rather have the loggers running and allow us to help you than not. It's only when the logger's out of warranty and has been damaged by, say, a lightning strike that at that point you would need to purchase a new one. But generally speaking, if we can fix your logger, we will do so. Assuming it hasn't been damaged through negligence or you know, physical damage, then we do so for free. That's been my experience, at least with Solar MD. Again, a value add. Okay. So the logger itself, as I said, is a router. It can connect to a network, and it can also provide connectivity, Wi-Fi connectivity to devices on site. It runs a DHCP server, meaning that it gives out IP addresses to your client devices. I don't suggest in most cases using it as trying to put too much traffic through the logger. It would be better to connect other devices on site directly to the core network, for want of a better description. Okay, moving on. So we're going to look at the MyPower 24 portal that you can, just to give you an idea of what you would see as the average installer. Just keep in mind that the permissions that I have and all the various settings that I have would differ greatly from what the average end user would have or the average installer would have. So there's going to be a few extra buttons and tabs that one wouldn't ordinarily see. So I'm not necessarily going to look at a high voltage site at this point in time. I'm going to show you a vanilla installation, of which there are many, just to give you an idea of what one can see or what one can do via the portal. I'm not looking at the questions, as I'm obviously involved with the presentation. I don't know if anyone else can see questions. Is there anything pertinent that needs to be answered now? Anyone from IBC? Can you see any questions that need answering?
Yeah, I think Carl and Leah have been doing a very good job in answering all the questions with the genres.
Okay.
So I think everything is sorted. Yeah.
Happy days. I hope you guys are still awake. But anyway. Okay, so I've picked a standard expert installation. This is just a residential domestic installation here in Mornington in Cape Town. So in order to access the portal, okay, you would need to create your user account. So let's say you're new to the brand, you've never logged onto our portal before, you've just bought your first logger. The first step is to get the logger online and connect it to the local network via cable or Wi-Fi, as I said. And you need to basically be invited to a logger. And from that invite, which is received via email, you'll create your user account, okay? And this user account initially will not have any permissions. So if you are an installer, you'll have basic viewing rights, and you can see basic stats and graphs and a bit of history and error logs and that kind of thing. At that point, you can contact the technical support department and request additional permissions that we can assign to your account. So once you've logged into the portal, you can see your list of loggers on the top right hand side. I'll get into the specifics on what you can see on the battery and look at some of the configuration in a minute. But just looking at a couple of very basic features, you can add, if my browser will work, you can add pictures of the installation, which we'll see on the left hand side. So you can upload a few pictures of the customer's installation to the portal, and that would be displayed on the top left-hand side, where in this case it says Darren Rogers, who's just an end user. You could see a picture of what's installed, and sometimes that helps when it comes to troubleshooting, just to know what you're working with. If you've done a few hundred installations, you're not going to remember the specifics of every site at the drop of a hat. So you can upload photos, that's handy. You can access those photos and browse through them. Actually, it's beneficial to our support team as well to have that kind of information available to us, but that's a very, very basic thing. So you can look at the dashboard here once it loads. This is the generic dashboard that one uses for the average residential installation. The dashboard and layout thereof of industrial installations looks a bit different, a little bit more professional, if you will. But here we can see the solar production. We can see the load from the house. We can see, the charge that's going into the batteries, as well as the remaining charge time, and the battery state of charge, the total size of the installation, and essentially how many kilowatt hours are in the batteries at this point in time. The reason that we're able to see the load from the home and the solar production is that in this case, the customer has a Voltronics Expert inverter, and that's connected via RS-232 or serial in layman's terms to the logger. So the logger is able to receive this information reported by the inverter. So it's just reporting what the inverter is reporting. The battery information, however, is direct. So via the CAN bus 1 communication port on the BMS, that's reporting straight to the logger all of those stats. So it's a culmination of inverters values as well as batteries values as well. So that's just for a quick overview. You would see this on the app and on the portal. I think it's worth mentioning that the app at this point in time is primarily used for monitoring purposes. If you're wanting to make significant configuration changes, then you would access the MyPower24 portal via a web browser. This could be a web browser on your computer or the web browser session on your smartphone. So the app at this point in time is for remote monitoring. It's also worth noting that our R&D team is constantly working on the app as well as the portal, continuously adding features. We've got a new dashboard that's going to be out publicly available soon. This is what you're looking at now is version 8.5. Version 9 will have a fully customizable dashboard. I can't go into too much detail because I don't actually have all of them myself, but you can add and remove. It's sort of a modular design where you can sort of drag and drop and add and remove the bits that you want to see, as opposed to this predefined, somewhat static layout. So it's much more customizable, which is the modern way of doing things. So the app is undergoing development, and so is the portal. We're adding new features all the time, adding support for new devices as well. That side of the team is growing. Their knowledge is growing, and I mean this is a value add of dealing with SolarMD. Again, this portal, this logger is not a service that we charge for. It's a value add. You know, when you buy the logger, you're really just paying for the hardware platform. There's no subscription service. There's no licensing fees, and so on. And I think thinking back to my previous employer, which was another battery manufacturer who I'd rather forget, if you're dealing with a problem on site, having a logger installed means that you can take care of things remotely. And that sounds obvious. However, with other brands and their battery BMS design, if you wanted to make changes and diagnose the problem, it would necessitate you being on site and using a USB cable and standing there in person, connecting with your laptop to the BMS to correct the problems. So some battery manufacturers do not have the ability for you to address any issues or give you any insight remotely. In our case, with the logger, it's innate. That's what we do. So there's plenty of situations where our support team is able to rectify the problem remotely, or at the very least, advise the installer as to what the problem is and tell them what the best course of action is to correct said problem. And we can do that, you know, from the comfort of our air-conditioned office, and we don't necessarily have to ask anyone to be on site. Okay. So that's sort of a key feature, I guess, I missed when it comes to why one would want to install a logger. Okay. So that's looking at the dashboard itself. Again, there are different layout options. This is a basic residential installation. Again, you can see that they're not pulling any power from Eskom at this point in time. We can look at the charts, I suppose, before I get into the my devices, because we're looking at the dashboard. We might as well look at the charts. You know, these charts, forgive me, I don't have the best layout, and some of the values are obscured here with the relevant numbers to make the chart more relevant. The reason for that is that personally, I work on this platform every day. I've inverted the colors. I forced it into dark mode just for the sake of my own eyesight, because I look at this 8 hours a day or 9 hours a day. So your experience will be a bit different. The colors will be inverted. The charts and the values will be visible. So forgive me. But looking at the charts, you know, you can expand this out to 7 days, or look at it in a single day. You can go from the macro, which is the large, to the micro, and you can look at a much narrower time slice as to what's happening with the system. You know, so looking here, you can see that the PV production at that given time was 6.5 kilowatts. Loads were about 4. the state of charge of the battery, the pack voltage, and so on. And then the fact that there's no power coming from the grid. So it's quite flexible in terms of the timeline. The logger uploads all of this information to the MyPower24 portal. So it's getting some. So all of this information is stored historically. So assuming your logger is online and it does have a buffer, if it goes offline temporarily, all of this information is recorded on our servers. And so some of our customers have had loggers installed, for 3-4 years, and we can scroll back and look at all of that information, which is in some cases very, very useful if you're wanting to see long-term data. Okay. So yeah, that's just the graphs in terms of production and loads. Energy layout can show you how much the battery is being discharged within a given day, PV production for the day, loads for the day. This makes it very easy to diagnose whether or not you have sufficient PV production. I mean, that's pretty obvious here. So, if you see that your loads exceed your PV production, let's say during summertime, well, you're going to be having a challenge during winter time when your PV production is less. End users will tend to ask very, very basic questions like, why am I using so much power from Eskom? And you can go, well, look, your PV production is low. And if it shouldn't be low, well, then there's obviously a blown fuse, a circuit breaker that's tripped on the PV side of things, whatever the case may be. But this sums it up quite nicely. You can look at this over a single day. You can look at it over a week's period per day. You can look at the production and loads and so on for the week as a whole, for the month. And if you have enough data, you can look at these values, over the course of years, which is why I've chosen this older installation. Okay. Of course, all this data is useful to you to a degree. It depends on how you choose to interpret things. If you have any questions thereof, then you must just reach out to the support department. Again, you can phone in on our landline. You can email in if you prefer to take longer with your communication, or you can message us on our WhatsApp line. Our WhatsApp chat number is available on our website in case you ever forget what it is. In terms of low voltage support, since we're on the topic, there's 7 of us who can assist you. It's always the same number, and we can assign, your support chat to any one of our agents on the fly. So if you prefer to deal with a particular support agent, you can just ask for them, and we can continue helping you in that regard. The same also applies with our high voltage team. So we use in terms of a good after sales value add, we don't use WhatsApp Business or some sort of generic WhatsApp platform. We've invested in a company called Freshworks and their software solutions, specifically Fresh Chat is what we use for the chat platform. It's an enterprise grade management solution that allows us to record all of our chat history. So if anything is ever said by our agents or by yourselves, we can always refer to that history if need be. There's always evidence of what is said by both parties, and that obviously is useful in a number of cases. So all of that information is recorded, pictures, and so on. Our teams can also chat privately. So if an agent needs additional, I need to support them, they've got a complex query, I can also chat with them privately during that session, and they're better able to support the installer. So it's an advanced platform. All the information is recorded. That integrates with our ticketing system. So let's say we need to send you a replacement part. We'll create a ticket on Freshdesk that's email based. You'll receive a copy of the email with the description of the problem and a ticket number. And that's your reference number when it comes to dealing with any warranty claims, replacement parts, repair queries, all that kind of stuff. And that ticket number, that ticket's actually integrated right into the chat. So if I'm dealing with Joe's Soap, I can see my chat history going back as long as we have been chatting. I can then see the ticket numbers and the open tickets that they have. So, maybe the installer's been dealing with myself personally, I'm on leave, and they're now dealing with someone else. That support agent has access to the entire chat history as well as any open tickets. So it just allows us to be a bit more consistent, and you know, be on the same page if your preferred agent isn't available at the time. Okay, so that's enough about Fresh Chat and Fresh Desk, but I'm just telling you about this, you know, the back end of what it is that we do, because we do take our after sales support seriously. It's not perfect, but it is undergoing improvement. That's one of the reasons that SolarMD hired myself. And so, you know, I can say quite honestly that one of our co-founders, you know, Kalyan, his core focus, his whole mantra is all about after sales support, keeping the customer satisfied. And he has very, very high standards in that regard, and we try our best to try and meet those standards. So I think there's a lot of brands out there in the market who simply stick their label on a battery that they don't produce, that comes from China. They drop it off in the market and they leave you alone to suffer. You know, everything, as Riska explained, is in-house, and we do care about our relationships with our EPCs and end users. You know, there's end users that we still deal with that have been dealing with SolarMD. They still have our batteries from our inception, from 8 years ago, from 10 years ago. We're still helping them. We're still supporting them. And that's great. It really is. Okay, anyway, so getting back to the topic of the dashboard and the charts, it is possible for us to, and I don't think I've done it in this case, to log the data of each and every battery installed on site. And this is a feature that we enable if need be. So let's say you have 8 batteries installed on a site, and you're trying to diagnose as to which one may have a fault or have a low cell. We can enable additional logging that'll record the pack voltage, the state of charge, all the parameters of each and every individual battery, including the cell voltages, and graph all of that data. And that allows us to diagnose problems in a heartbeat. So we'll record, you know, 24 hours worth of data, and then be able to better diagnose any problems. It's just a very powerful backend feature. I thought it's worth mentioning. So looking at the devices, so what you're looking at here is the logger, which is on the bottom left, and we'll look at that in a moment. You're looking at the batteries here on the top center. You're looking at the relays, top left, the inverter on the right. Let's just take a quick look at the logger itself. So I'm not going to go into too much detail because we're going to run out of time, and I think I've already taken too long as it is. But here you can just see the basic stats of the logger, what software version it's on, available memory, uptime, these kinds of basic stats. Necessary if your logger is running out-of-date software. It's worth mentioning that all software updates on the BMS, on the logger, are free. There's no cost. If the logger is installed, the software updates can be done remotely. So we can update the logger software. We can then go and update the firmware on the batteries as well remotely. So you as the installer would be primarily interested on the logger when configuring it on the networking settings. And so here you can see a list of the available Wi-Fi networks. So you can see here the logger broadcasting its own network, and you can see the customer's network here. And if it were connected to the customer's network, you would simply click on it, put in the Wi-Fi password. You'll see here on the left-hand side that it's associated. Below that, the TCP/IP, the IP address, all that data would populate, and then the logger would be connected via Wi-Fi. But in this customer's case, it's connected via Ethernet, LAN cable for, to use plain English. And here you can see that the logger is connected, what the IP address is, and so on. And so the logger is available on the customer's network on the following address. Okay, so if you had to type this address into your browser, if you were on the inside of his network, you would get the logger's web interface. It has its own native web interface, just like your average router would. But it's available on the portal as well. However, you could also access the logger via its own Wi-Fi and Ethernet port. So if you had to cable your laptop into the logger directly, the default address, which is written on the front of the logger, is 192.168.222.1. You could access the logger via that. So it's actually accessible in 3 ways: via the online portal, via the customer's network on that fixed on that address that it has at the moment, and then via its own fixed IP address via its additional Ethernet 2 interface and Wi-Fi interface. The local web interface on the logger is used for basic configuration. For the more complex configuration requirements, you would use the online portal. So the local web interface is basic config only. And I think in the near future, we'll actually do away with the local web interface, and it'll be purely app-based, an app on your smartphone. Okay. So here, if you're looking at under install devices, and this is beneficial to the average installer, you can see which devices are online and offline. As is most things on our platform, green is good and orange is a warning. It means something is potentially offline. But that's just a quick overview. I'm not going to go into more details on the logger itself here. On a logger related topic, if we look at the relays that are on the logger, here is where you configure the relays. And you can use these relays in two different ways. Well, you can not use them at all. You can use the relays and manually trigger the relays by switching them on and off, which can be configured, or you can automate that process. So here you would be configuring the relay rules, and you would say, I want to control this relay via a expression, and this is where you would define what those expressions are. And you would say, okay, if the battery voltage is less than 52 volts in this case, less than 52 volts for more than 5 minutes, regardless of the time of day or the day of the week, you might choose that the relay turns off, or you might choose that the relay turns on, depending on your system and whether it's normally open or normally closed. But you can define these values here on the relays. I'm not going to go through the process of setting it up in the interest of saving time, but you can use voltage, you can use state of charge as an example, as two parameters to start your generator. Or in some cases customers do very basic things, like if the battery's running low, they have the relay close, that activates a light, closes a circuit, and the big red light in their lounge turns on. Some people choose to do that. That's just one simple example of how people use the relays. Over here, let's take a look at the batteries themselves. So this customer's got a low voltage installation with our older 7.4 kilowatt hour batteries. In his case, he's got 4 batteries, and we can look at the parameters, and we can look at the stats on any one of those batteries at any point in time. So this is an installation that's been running for quite a few years. You can see the current state of charge. We can see the current limits, the minimum and maximum cell voltages, the status of the relay as to whether or not it's open or closed. On the right-hand side here, you can see the cell voltages. We can see the temperature of the BMS itself. We can see the temperature of the circuits that balance the cells. And then in some cases, with some batteries, they have multiple external temperature sensors that are in the multiple external temperature sensors inside the battery pack. And those values would be on the BMS and recorded there as well. So we had a question. Say it again. Okay, never mind. Excuse me. Right. So that's looking at the individual stats of the battery. Here you can see the cluster values, which is the combined values that are being sent by all 4 batteries to the inverter. So the total charge and discharge current limits, the average voltage of the 4 batteries, and so on. This is what's reported to your inverter at the end of the day. So you can look at the individuals, but here you can see the data that's getting reported, and then minimum and maximum cell voltages for the cluster itself. As the installer, under your installer settings, you can change the LEDs and what the push button does. So you can disable the lights on the push button if need be. Some people install their batteries in special locations, like, I don't know, their bedroom or lounge, and they don't want an LED glowing into their eyes in the middle of the night. You can turn the push button off, the LEDs. You can set it to a static color, or you can have the color on the push button display the state of charge. Here under control are some of the more interesting features that you as the installer have access to. So let's say the battery has been overcharged or over discharged. the relay on the inside of the battery would open. It would physically disconnect the battery from the DC bus to protect the cells for whatever the core reason was. And it might be time now, once maybe the problem has been corrected. Maybe the inverter was configured incorrectly, and it was the floats voltage was set too high, as an example, and you've now corrected that and lowered it. You can force the battery to turn on, okay, to now discharge the battery for a given period of time. In this case, I'll just do an example. We'll force the battery off. This can be done via the push button directly on the battery from the BMS if need be, but it's a lot easier to do so via the logger. So by doing this, the relay on the battery will open for 5 seconds and actually turn it off for 5 seconds. It'll time out and then close again, but you can force the battery on and off. If these batteries were communicating directly with a SunSync DEA inverter or a Victron GX or an SMA, this is where you would set that on the individual BMS. So you would select your inverter brand of choice and then hit set over here, and then the battery would start communicating with the inverter via its CAN bus 2 port. Right, so as I said, it is possible to upgrade the firmware, the software in layman's terms is running on the BMS. In this case, Darren, the end user, is running the latest software variant, which is 191. And you would do the software upgrade here, and you would say, okay, check online for the latest firmware, and it would come back and say, yes, we've got 192 available as an example. You would download it. It's a small file. It's only a few hundred kilobytes. And then you would upload it to the battery, and you would choose the install option. That would then install the firmware onto the BMS. The BMS would turn off and on, because it's essentially like formatting a computer. It's going to have to shut down and reboot. So keep that in mind. So in this case, he's got 4 batteries. If you do firmware updates one at a time, the system will continue running. If it's an off-grid system and you've only got 1 battery, well, then you're going to have to time your firmware upgrade very carefully. Okay. Right. So in this case, I can see it looks like Darren has upgraded here from his Voltronics Expert inverter to a DEA SunSync. I use the 2 brands names interchangeably because DEA is the manufacturer of the hardware platform, and SunSync runs their own slight firmware variant and rebrands the product. But the underlying communication protocols and everything are the same, so it doesn't matter which you configure on our platform. But here, this is the information that's being reported by the logger to the DEA SunSync inverter. You could do this communication directly from the batteries, but in this case, the customer is doing so via the logger itself. Okay, so if you're trying to troubleshoot problems, looking at the events tab can often, give you a brief overview of what the problem is. And so we can see here, it's all time stamped. You can see on this particular year, on this day and month, at that time, one of the batteries was discharged too far. If it's one of our modern BMSs, it'll tell you all the parameters. Those are all captured at that point in time when that event occurs. It'll tell you that the capacity was 15% remaining, what the minimum and maximum cell voltages were at the time, and so on. So that helps you have a historical view of the system. So you can see if the customer is consistently running short of power, if they're draining things too far, and so on. The errors are the more serious warnings. Events, should I say, warnings are, things like this, where in this case, the Expert AI, which is the Voltronics inverter, is saying is disconnected. That makes sense because the customer's upgraded now to a SunSync DEA inverter, so one would expect to have that warning, and we can remove the device off the logger itself. I'm just trying to think of where to go next. What else I want to show you? There is more to the platform than this, but I think I've taken up enough time on that topic. So perhaps we should get back to the remainder of the presentation. Kyle, IBC, is anything else that you would like to add, perhaps? If there's any features that you feel like I'm missing that are worth mentioning?
No, I think that was a very technical training, a lot of information to digest. So I think that for today's session will be enough. I think there's still more that we can learn, but yeah, thank you for the training on that.
Okay. Forgive me if I went too long, but that's what happens if you let someone like me in front of a microphone and have a captive audience. Okay, so here we just got a screenshot of one of our high voltage batteries, and what one could see on the portal if you were looking at them. You're going to get the overall stats from the BMU, which is the heart of the high voltage battery, and then you can look at the individual modules and the individual cells within those and their voltages within those modules. So you can see everything you could possibly want to know in detail via the portal. There's no guesswork required. You can see whether the relay is open or closed. You can see the current coming and going from the battery, the state of charge, etc. Temperatures and so on. It's pretty comprehensive. Are you wanting to talk about this part, Jen? Okay, so I'm going to hand over to Riska. I'm sure you guys are desperate for a change in voice, as mine can be monotone. So here is Riska.
Thank you so much. Thank you so much, Warren. So I'll be covering our battery energy storage systems. So Warren delightfully went through our high voltage batteries. So what we've seen recently is that there's been a big shift in the market towards more commercial and industrial solutions. And we as Solar MD cater to this demand as we design and manufacture our battery energy storage systems. So if you are looking to move into the commercial market, you can call IBC. We've recently worked on an over 6 megawatt energy storage system, so a base container. So anything from 1.5 megawatts upwards, I mean, the sky is basically the limit. So at Solar MD, we are responsible for design, and like I said, we are able to scale this up with our high voltage batteries. We also allow for a hybrid power setup. So this container, once it's installed on site, can be connected to generators. It can be connected to many different alternative power sources to allow for the best cost savings for the client. It is modular and efficient, and we allow for quick installation for the containers. So it's good to note that we offer two different kinds of containers. So we will either offer a standard battery container or a battery and inverter container. I know that Warren mentioned something about ATIS inverters, but we will supply SunGrow and Kawutek inverters. And then if you're looking to maybe install a high voltage ATIS, you would need to, as the client or the installer, supply the inverter yourself. And then also to add a little bit more onto the specific features of our container. So like I said, these containers can range anywhere from a 20-foot container, 30-foot, 40-foot containers. And some of the features of these containers is that all of our containers have a container auxiliary back wall, which we call cabo. And essentially what that contains is the air cons. So we supply our containers with 2 aircon units. So we essentially supply it with 2 36,000 BTU Medea aircon units. And essentially these aircon units, so we supply 2, so the additional one is for redundancy, as one of these aircon units will cover around a 39 square meter cooling range. So they are quite, they have a lot of force. And so we usually have the 2 at the back of the container. Also with our containerized solutions, we try to keep all of the connections outside of the container. So we will have our DC connectors, as well as our external connection boxes on the outside of the container. And this is obviously for safety purposes, as we are talking about 1 megawatt plus power. So those are just some of the safety features, but also one of the important features that we do have in our battery energy storage systems are our fire suppression system. So we essentially have a FirePro fire suppression system. And how this works is that within the container, there are, we basically offer a 3-zone panel, and the fire suppression system consists of both heat and smoke detection. And what happens is the concentrated aerosol generates potassium carbonate radicals, and these will dissociate within the base container. And therefore, the oxygen levels will decrease, but not necessarily to a point that will be harmful to humans. However, in the case of a fire, we obviously urge everyone to evacuate immediately, but this is some of the added safety features that we do have. We specifically offer a Sigma XT fire panel, and these fire systems, the fire suppression systems that we have in our best containers, are designed by external consultants. These external consultants are SAQCC certified. Further to that, they're also installed by installers that have the SAQCC certification. So that is basically the South African Qualification Certifications Committee. And then also a little bit more about the fire suppression system. So upon activation, the FPC compound, like I said, will be transformed, and essentially the component or the compound that is in the fire suppression system is your potassium carbonate that essentially reacts and thereby will extinguish the fire. Another feature of our fire suppression system is that it is spaced according to the room volume of where the batteries are. So like I said, we generally supply a 3-zone panel for heat and smoke detection. And then additionally, added features or add-ons within our containers are our battery. We also have battery UPS. We, like Warren said, in our high voltage systems, we always have a logger for communication. And then also we have our auxiliary distribution board. And another key feature that we have as SolMD is that our mechanical engineers essentially have designed and manufactured a hoist rail. So our batteries are quite heavy, and especially in these containerized solutions, we are talking about stacks of batteries. So the hoist rail allows you to lift the batteries up and essentially move them around in the container, and this also comes standard with our containers. And then moving on to the last slide, like I said at the beginning of the presentation, our mechanical engineers are highly involved in our battery energy storage systems. They are involved in the initial design, and we essentially have a set process. So there's drafting of the preliminary layout. So important is that our battery energy storage systems are also customizable. I mean, as time has gone on and we've grown, we've standardized on some of our containers, like our battery-only containers, but generally it is customizable. So, like I said, anywhere from 1 megawatt onwards, sky's the limit. And then, yeah, so back to the mechanical design. So we will present this to the client as well as our partner. In this case, it would be IBC. So we would go back, finalize the design, and our mechanical engineers as well as our production team will essentially manufacture this entire container from start to finish. So that is the cutting, the welding, cladding, so internally, as well as anything electrical and mechanical. So like Warren said as well, the high voltage market is definitely picking up, and yeah, so it's definitely the new way to go.
Can I add something?
Yes, you can.
Look, just from my limited perspective, and with my brief time with Solar MD, which is only a year and a half, I've watched the designs on these containerized solutions improve incrementally over time. Literally every container or every second container that is produced has a slight improvement upon the last. And it's just getting better and better all the time. And I think the designs of these of our containers speak for themselves. And I would invite any one of you who are interested in offering these solutions and so on to pay us a visit at our factory when we have one of these under construction, and to come have a look and to see how things are done and how they're put together, and look at the overall design. I mean, it's all good and well looking at a YouTube video or pictures, but I think if you're standing inside it, you can get a better appreciation of the amount of care that's put into the design and how comprehensive it is. Because we're multiple generations of designs down the road, and there's no shortcut. There's no shortcut to that process. So there's a lot of other people offering containerized energy storage solutions at the moment, but they're basically taking vanilla batteries, throwing them in a container. So technically it meets the requirement, right? But it's not really sophisticated. And so I think the product speaks for itself, and I think if you're going to be spending money on a product of this type, it's worth paying us a visit. Let the product speak for itself, so you can understand what it is that you're buying, what it is that you're investing in.
Thank you, Warren. Yeah, so on that, I do have a little YouTube video just for you to actually just have a look at what one of our containers looks like on the inside, and for you to better visualize everything that we're speaking about. But definitely come around to our factory and have a look to see for yourself.
Okay. Let's see, I clicked on the link. Okay, so the hyperlink's not working. I'm going to have to do this the manual way. Forgive me. I think since the audio didn't work last time, I guess we'll just have to give you a voiceover on the fly. So yeah, the size of the container depends obviously on the customer's needs. Some are 20 foot, others are 40 foot. Because the design is modular, we can pre-populate most of the container with the battery modules and inverter if that's what's needed. And then the rest of the key components can be sent separately. As you can imagine, a container of this design, once fully populated with all the energy storage, is going to be quite heavy. And there's weight limitations on the cranes, the road freight limitations, and so on. And so because the design is modular, we can send as much as possible, and then send the remainder of the components separately. And then the rest of it can be assembled on site. So if you look on the roof there, you can see the monorail, for want of a better description, that allows you to slide the battery modules in and out and change them as need be. You saw that was our old design of fire suppression system. We have greatly improved the fire suppression system on the inside of the containers, not because there are frequent fires, but rather to meet the necessary industry standards and legal requirements and so on. And I believe that was the end of the presentation. So are there any questions that we need to answer?
Yeah.
Anything more?
Thank you so much, everyone. Is there any questions?
Thank you guys for that. Let's just see if there's any questions here. I think Carl did a very good job in answering all the questions by the looks of it. Yeah, in case you miss any questions, please feel free to drop to contact SolMD. They do have a WhatsApp line, which we will then shortly put up onto our chat group, or you can just go online to SolMD's website and you'll find their WhatsApp contact, the support number there online. Thank you, Warren, and thank you, Riska, for the presentation. That was a very fruitful presentation, and I think most of us learned a lot today. And without further ado, I think we can just then call the end of the presentation. And we just want to thank everybody who showed up, and just thank you for taking the time out of a busy schedule and just coming to join us on this presentation.
Alton, just one thing to mention quickly. There is an in-person training next week at our office. So if you want to sign up for that, the link is in the chat.
Okay, perfect. So if you do want to sign up, as Carl said, the link is in the chat, and just make sure that you did register for these trainings, because the video will be available for this training, which will be sent out by Zane. I'm not sure, MD, will this presentation be available to the public?
I'm sure we
Yeah,
can
we
make it
can.
available.
Yeah, we can upload it to our YouTube channel for everyone to view.
Well, in terms of the actual PDF, I'm sorry, the presentation file, we can share it with you.
Yeah.
Okay, perfect. And then, yeah, I think when we send out the videos, we will then attach the presentation. Thank you, guys, and thank you, everyone. And then, yeah, I think we can call it the end of the presentation.
Yeah, thanks very much. Hopefully I added some value to your day.
Thank you. More than enough.
Alrighty. Goodbye.